Okay. So if anyone have any questions, let me know. Otherwise, we'll start up. Okay. So today our topic is disk management. Okay. So in the Linux admin, disk management. What is mean by disk management, right? Why we? what is the mean of disk management here? Okay. See, guys, in the actual real time. Okay. So if you take any disk, okay, or not a disk, for example, you have MySQL database, or for example you have Oracle database, or any applications, or application logs, okay, or application related files, okay, or any scripts. For example, if you have any scripts, you wanted to keep all the scripts into one directory. So what you do for the MySQL data, you require a separate partition. For example, in case like slash boot is a partition, right, file system, right? In the same way, slash is a file system, right? If you run lsblk command, right, you can see all those, right? So let me see that thing. So I already logged in here. So if you run lsblk here, lsblk, okay, you can see sd as a disk here. It is 20 gig gb, I mean 20 gig, right? There is a disk. Slash boot is a partition, and then sd2 is the like a normal partition. In that, like, we have slash is a lvm partition, and again like 2 GB of swap partition, and this is actually cdr dvd, right? You have two partitions here, two file systems. One is slash boot, another one is slash. Slash boot is a normal partition, and then slash is a lvm partition, right? So if you go to slash here, give lsblk, right? Oh, sorry, give ll. You can see here slash boot is the directory, right? So here in this boot, what is the space here? 1 GB, 1 G of boot. Until 1 GB, like, we can store it in this. Again later, like, slash is a file system. I mean, bin dev etc and all, there are many other partitions, right? Including all these, we can store up to 17 GB, because 17 GB is free here, right? So that is the thing. For example, in the real time, like, you will get the use cases. For MySQL database, I want separate partition to store the data. MySQL data, something like this, okay. Or for Oracle database, I want like a different partition, okay. So what you can do for Oracle database, slash ora data, something like this, okay. And for applications, right, so slash app data, for example, or application logs, slash app logs. For application like files and all, like application files, if you want to create separate one based on requirement, okay, slash app file, something like this. For scripts, slash all scripts, okay, something like this. So what you need to do for this, you need to create a separate partition. Let's say I have in my windows, I have only one partition, that is c drive, right? So if you create multiple partitions on a disk, c drive, d drive, u drive, something like that, you'll get multiple partitions, right? So in the same way, here also, like, if you want to create for MySQL database, Oracle database, applications and all, you can create separate partitions, and then assign to a application, assign to a like a file system, okay. That is what we are going to do with the disk management. This is the main requirement, okay. We'll discuss type of party file systems, and then type of partitions that we have, okay, in the Linux, that we'll discuss, okay. So now, so you can see, right, disk, in the disk management, like, if you take any storage device like ssd, hard disk, SCSI hard disk, like small computer system interface, it will be in the VMware. And EBS, actually, Amazon Web Services one, okay. We can extend directly. So I'll tell you later this one, I mean, in the AWS concept, we'll learn it. So yes, KZ hard disk we are going to discuss. Hard disk and SSD both are same almost. right? So we get these two in the physical environments, kind of hard disk we get in the physical environments. Okay, so let's see, right? You need to know a few things here. What are those few things mean? Blocking storage devices, right? So all these are like blocks. So hard disk is a block storage. What is mean by block? Okay, one block equal to one sector ma, that is called 512 bytes. What is meant by block here, that you need to know, right? So what is meant by block? So I'll tell you now. So for example, if you take this, I hope you can see, or else I'll open in a browser. Give me a minute. Open with somewhere. Okay. Okay, so here you can see, right? So here, if you see, let me take in the snipping tool. Okay, so in this snipping tool, actually, um, you can see the disk architecture. Okay, this is the disk architecture that you need to know first. Okay, see guys, you might aware already hard disk, right? How it looks like. If you are not aware, I'll show you quickly. Okay, so hard disk. Okay, you can see images. You can see the hard disk. These are all the hard disk. This is one hard disk, this is one, this is one, right? You can see like here this is the disk, and here you can see this is actually stepper motor or spindle motor. Okay, so all those things you can see. Okay, now this is actual like internal stuff. Okay, whatever you can see it here. Okay, whatever you can see it here, this one, right? This one actually acculator, we can also call it as stepper motor. Okay, it means it is used to read and it is used for like read and write operations. You are creating a file, it will write the data. You are opening the file, you can see the data, right? I mean, you can just read the data, right? That is kind of stuff. Okay, so next one is, this is all like each circle you can see it here, right? It means this is actually track. You can see that is track. Okay, give me a minute. Okay, this is actually track. You can see this is a track, and this is also one track. One circle is one track actually here. Okay, so you can see this is actually, you can see sector. This is actually sector, this one and this one. If you see, if you draw something like this, right? You can see one block. You are getting one block here, right? One box. One box is called what? That is actually sector. That is called sector. Okay, so how many sectors we have? Each block we can call it as a sector here. Each block is sector. That means one sector, one block means one sector. That means 512 bytes. Okay, so if you take actually 512 bytes, one sector equal to how much? One sector equal to 512 bytes. Okay, two sector equal to how much? Two sectors equal to 1 kb, 1 kilobyte, right? Something like this you can calculate. 1 GB equal to how many sectors you can calculate, right? So this is actual stuff, actual blocking storage, which means each block will be one sector equal to 512 bytes. It means like two sectors equal to 1 kb, something like that. So you can calculate for GBs, kb, mbs and all you can calculate. Okay, so now I'll show you the actual stuff now. Okay, you have a 500 GB disk. If you want to create a partition, what do you do, right? So there are two kinds of partitions. One is primary partitions. There are three methods actually. Primary partitions. Second one is LVM partitions. Logical volumes, which means logical volumes. Logical volume. Okay, logical volume management. Okay, Next, third one, RAID, redundant array of independent disk. Redundant array of independent disks. Okay, so there is different stuff, RAID levels and all we have. There we create. Okay, so now primary partitions, logical partitions, and RAID method. There are three kinds of methods. These are the three methods. Okay, so you have you know what is a disk, you know what is a block here, you know what is a sector, you know what is a byte, right? And you know like what is the actual partition types here, right? For example, and you also need to know the file system types here. File system types, what is meant by file system type, right? In Windows actually we have FAT32, PAD32, and then NTFS. Okay, so these are two we can see in the Windows basically. Not in Windows. For PAD32 we can see for pen drive. If you attach pen drive to a system, you can see file system type. And for NTFS actually in Windows. If you see here, for example, I have a disk here. This is the one. And if I check for the partitions, okay, you can see file system type is what? NTFS, new technology file system. That is a full form actually. Okay, FAT32 file allocation table 32. Okay, something like that. There are full forms, you do not require much about it, but these are the two file system which are available. Okay, what are the file system mean? What is mean by file system? In Linux we have ext2, ext3, ext4, and xfs. Okay, these are the like four types. In newly like they introduce there are few things actually they introduce in new Linux environments actually, new versions of Linux. Okay, so first of all, what is meant by file system here? What is a file system? Simply I'll tell you, file system you already know, right? What is file system? where we can where we can store the files in the form of directory structure, right? So for example, let's take this, let's take C drive. You have this one program files and users, windows, and all. There are many things here. If you open this, okay, for example, if you open program files, you can see all the files related to like Windows. I mean Windows related, like any software you install. Example, I install Notepad plus plus, I can see it here. Put a install, I can see it here, right? So all those things you can see it here, including Windows and the third party applications we installed. And if you see Windows, all Windows related files, right? It means like in the C drive we have all the file system here. I mean one directory, and inside multiple directories, and inside like subdirectories, and then subdirectories. In each directory we can maintain different files, right? For example, if you want to maintain all media files, you create a media, mp3, mp4, and marriage for marriage, and then childhood photos and all. You create folders, and inside each folder you will maintain for marriage, you will maintain like files and directories, right? I mean songs or anything, videos, or you can segregate the things, right, in different directories, right? So that is called directory structure you are maintaining. So all that require a algorithm, that algorithm defined by these file systems. Okay, so if you create ext4, right, you can create a number of depths. For example, maybe up to 16 TB, or not sure, not in my mind, up to 16 TB or 32 TB terabytes. You can create a file system. If you are taking ext3, it will be less. For example, your application data or anything required 16 TB one file system. If you want, then you should go for ext4, something like that, right? So there will be some limitations. We will discuss all this at the end of the this disk management. Okay. So, but these are file systems available in Windows and Linux. Mainly in the Linux, these are the things. Okay. You know disk, you know file system, I mean, file system type, what is file system. Now you know what we are trying to do here, right? So these three things you are aware. Okay. So what is disk, what is partition, what is file system, what is block, what is track, right? Right, what is block means like one sector equal to one block, that is mean by 512 bytes. Two sector equal to 1 KB, something like that. It means 2 MB file if you are storing, okay. It means 2048 KB, which means 2048 into 2 4096 sectors, right? That is the calculation. In the disk architecture, like spindle motor, stepper motor means spindle motor, stepper motor, in the sense I'll show you here. Okay, for example, this is the one. You can see there is a this is the middle one, right? It will spin, actually this is spindle motor. It will spin the disk very fast. Stepper motor, in the sense you can see it here, right? This one, the white one, that is a stepper motor used to write and read operation purpose. Okay, that is spindle motor, stepper motor. Okay, you know what is track now. Okay, cool. So now in the disk architecture, like in the disk partition, there are three methods you already aware, right? The measurements and all, like 8 bits equal to 1 byte, and then 124 bytes equal to 1 KB and all, like memory management. If anyone don't know, just go through it. Okay, now you need to know one more thing. Hard disk, SSD, or whatever you assign to a system, how it will be. Okay, for example, you assigned a hard disk, that is SCSI hard disk we use in VMware. So if you attach the first, if you have one disk means slash dev slash SDA. You have two disk, slash dev slash SDB. You have three, slash dev slash SDC, something like that, and so on, like ABCD, serial wise it will come actually. Okay, so if you are assigning fourth disk now, what will be the disk here? Slash dev slash SDD. You're getting it? Slash dev slash SDD. Next one, if you are attaching slash dev slash SDE, something like that. Okay, so that is what you can see in this, actually whenever you run the command here. Okay, so let's, okay, so lsblk, if you run, you can see SDA is a one disk. These are two partitions, right? SDA1 is one partition, SDA2 is another partition, something like that, you can see. If you're taking one more disk, SDB will come actually. I'll tell you like how to take and then how to run that and all. I'll tell you, okay, bit later. Okay, you are done with this, right? Now I'll tell you about primary partitions. I'll discuss LA partitions later. Okay, see guys, what are mean by primary partitions? Okay, first thing is primary partitions are bootable. Primary partitions are bootable, which means if you are installing if you are installing OS in primary partitions, okay, then you can boot the system. If you are installing in LVM partitions, we cannot boot actually. So primary partitions are bootable. Okay, so if you want to create a slash boot file system, for example, without slash boot we cannot start up the system, right? So it should be definitely primary partition. That is the reason you can see the primary partition here. That is the part means it's a primary partition. Slash is LVM partition, so slash can be anything, but slash boot definitely a primary partition. So that is the reason minimum partition required to start up the system is slash boot. Slash boot is definitely required to start up the system. Okay, next one is, we can create up to four partitions. Four partitions per disk. Per disk, actually, we can create only four partitions. Okay, so you have, for example, 500 GB disk. Okay, 500 GB disk you have, or 1 TB disk you have, 1 TB disk you have. Okay, you are creating a primary partition. You are creating secondary primary partition, third primary partition, and the last one is extended partition. Okay, why extended partition means, for example, for this first primary partition I'm assigning 200 200 GB. Okay, 200 GB I assign here. Second primary partition, I'm assigning again 200 GB. For third primary partition, I'm assigning 200 GB. Okay. For fourth primary partition, there is no chance to like apply here because already 600 is done, only 400 is left. So if you are creating another partition, definitely it should be external partition with 400 GB. In this 400 GB, you can create n number of, okay, in this 400 GB, you can create around 65,535 LVM partitions. You can create 65,535 LVM partitions you can create in this 400 GB. For example, if you want to create only two partitions, one is for Oracle data, one is for MySQL data, for example, you can create them LVM partitions in this extended partition. Something like this, which means we can create only three primary partitions per disk and then one extended partition. Okay, so something like this. That's the reason you can see here slash boot is a primary partition and 19 GB I took a separate partition, that is ST2 SDA2, and then you can see slash is a LVM partition, swap is a LVM partition here. We'll come to that, like LVM, what is LVM partition, what are the advantages and all, will come to that later. Okay, so this is actual stuff now. Primary partitions are three, and then LVM partition, LVM partition we can create in the extended partition. This is one way of creating LVM partitions. There is another method of creating LVM partitions that is important, right? We have different method of creating LVM partitions, that is important. Okay, there is not like much important, but you should know. But I'll tell you like how to create primary partitions and all now. Okay, cool. So we can create this. Okay, next one is we cannot extend the partition without downtime. Without downtime we cannot extend the partition actually. What is meant by without downtime, right? For example, you have already a 200 GB partition which is assigned to MySQL data. Okay, slash MySQL data, you assign this 200 GB. Next to 200 GB you assign slash Oracle data, for example, or a data. Next is slash app data, you assign application data, app data or something. Okay, you assign this, 200 GB, 200 GB now. MySQL data, it is getting full. MySQL data is a file system, right, where we can store 200 GB. It is getting full, 195, almost 195. You need to extend the space. What you need to do, definitely you need to delete unmount this actually first, and then you need to create one more partition with the 400 GB or 500 GB you need to create, and then you need to assign this back to this one, right? And then you need to copy all this data, right? Something like that you need to perform. That will take that is the base method that you need to follow, right? In the simple way, you have a mobile, you have a hard, you have a just a simple the SSD will be assigning, right? That memory card, right? 32 GB memory card is getting full means what you do next, 256 GB or 128 GB, you take another one, you copy all the 32 GB data into the new memory card, and then you insert into your mobile, right? Something like this. It means which is downtime, right? Whenever you remove that memory card from your mobile, maybe it may take some time for you to copy the data and then inserting. Until that, maybe 2 hours or 3 hours or 1 day or 2 day, the data which is available in the memory card will not be available for you in your phone, right? That is called downtime. For example, I'm using HDFC bank. I wanted to see like last month data, last month what are the transactions that I have done. I'll download the bank statement, right, for that month, and then I'll look for each and every transaction that I have done at that time. For example, HDFC doing some activity, something like this, I may not be able to access that data, right? In that case, what I would think actually, hey, our HDFC is not working properly, the application is not working, maybe we need to search for some other bank, something like that, the people think, right? So that's not a good idea, right? So without downtime, if you are able to extend the file system, 200 GB is there on the fly. If you want to extend 400 GB, yes, that is fine, right? So if you want to go with that way, we need to go for LVM partitions. Okay, that I'll tell you later. So with downtime, we cannot. I mean, without downtime, we cannot extend the partition. Okay, these are the three things. I'll tell you now how to create a file system. How to create a normal file system. I mean normal. What to say? The actual primary partition. Primary partition, and you'll learn the same stuff. Okay. So let's go to the system. Okay. Let's go to the this one. First, actually, we need to get the disk, right. You need to get the disk to create the partition. So what I'll do is I'll request VMware team to get the new disk. If you have VMware access, you can also do it. If you have like vCenter access and all, you can do it. But usually in real time, we request a storage team if you have physical servers, VMware team if you have VMware environment. Okay, AWS, if you have access to AWS, you can go for it. If you have different team, you can request them. Okay, so you need to get the disk here. So what they will do is they will add the disk. So here in this AWS and I mean VMware environment, I'm adding a disk. In the same way, like you'll also have a same kind of environment there in the vSphere client. If you wanted to try, just go to actions and then do creating a new disk and all. There will be different steps. Okay, so I'm creating a disk here, hard disk, SCSI, next, and next. I'm taking 20 gig here. Okay, 20 GB, next, and then finish. Click OK. See here, I added one more disk. This is previously added, this is new disk. Click OK. We added a disk, right? Now we get the requirement saying that hey, in this system we already added the disk. Like that, we get the response from actually VMware team, right? We get the response. So what we do? Okay, fine. I log into the system and then I'll check it. Like that, you will say, and then you log into the server using putty, right? Root, and then log in with the password. Okay. Now if you run lsblk, you can see you don't see fdisk -l is also another command. Fdisk -l to see the disk information. Here also you are unable to see the disk. This is only one disk you have. You don't have any, like this is swap partition and all. You have only two partitions here and only one disk, that is /o/sda. SDB is not here, right? So lsblk also I'm unable to see. There is one more command, lsscsi, list out SCSI hard disks. Okay, only SDA disk is there. /sr0, this is actually CD. That is the other one, right? So what you need to do now? Actually, if you reboot the server, you will get the disk actually. Okay, just refreshing. But we shouldn't reboot in the for the real time servers or production servers, right? Production servers we shouldn't reboot. So what you need to do is you need to scan channel target LUN. Channel target LUN. So in the storage side, we have different channels and targets and LUNs, logical unit number, LUN, LUN. Okay. So as the command we need to run is echo hyphen. Okay. Double greater than slash sys. Okay, class SCSI underscore host 0 /scan. So hyphen means channel, second hyphen means target, for which target we have a disk, and then LUN, logical unit number. Okay, these three things will be at the storage end of VMware. Okay, these three things we need to scan at OS level. So here host 0 means HBA card 1. For which HBA card we attach, for example, for motherboard or whatever the device, right? There will be multiple SATA cables or whatever, right? Different hosts. It means different HBA cards. For which HBA card that we assign to a system, we don't know, right? Even VMware team, we don't ask actually, right? So if you do for host 0, this is HBA card 1. Here, host 0 in the sense HBA card 1. HBA card 1. If you are doing for host 1 in the sense HBA card 2. HBA card 2. Host 2 in the sense HBA card 3. HBA card 3. Something like this. Like you need to scan actually at OS level. So what you can do is you can repeat the same command multiple times. Okay. Same command maybe 3 times or 4 times. So HBA card has host 1, host 2, host 3, until HBA card 4 you can scan it and see whether the disk is available or not. Okay. So what is the command to scan at voice level means this is the command uh, you need to run to scan the disk at voice level. Okay. So echo hyphen 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 double greater than, right, slash sys class double greater than slash sys class skz underscore host 0 slash scan. One time done. And for HBA card 2 I'm running. For HBA card 3 I'm running. Okay. And for last one maybe three, I'm thinking only four are there. So I ran this. You can see here the disk is visible, 20 GB, right? So this is how you need to scan the disk at OS level. When the disk is available, you can create a partition, primary partition using fdisk. Okay. Next is you can create primary partition using fdisk command. Okay. So fdisk actually fdisk command. Okay. How to do that? I'll show you. Fdisk slash dev slash sdb. Slash dev is the one, right? Slash dev slash sdb is the second disk, right? You can see second disk. So just give enter. Here it is asking for M for help, right? Just press M and give enter. You are getting multiple options here. So you need to create a new partition, right? Add a new partition. You can see here n enter, right? And here zero primary partition, zero extended, four free. You already know, right? Four partitions you can create, three primary partitions, one extended partition. You can see four are free. We haven't created any partitions over for that disk, right? So you can see only four primary partitions, four free, right? So you need to give what is the primary partition, what is the type of partition, primary partition or extended partition. Default is P, primary partition. If you give P or give enter, it will take default using default response, that is primary partition. Now partition number default one, it will take default one if you give enter. If you take different number, it will take different number. So I don't want to give anything, it will take default one. Next, first sector, last sector. From which place to which place you want. First sector you need to give from this place to last sector from which place you want, you can give it. So first sector by default it will start with 2048 sectors. 2048 sectors onwards. 2048 sectors it will occupy, 2047 sectors it will occupy for metadata information. So it will start default, that is the starting point. Now we have 20 GB disk, right? For 20 GB disk, this is the last sector. This many sectors are available for 20 GB. If you calculate for 20 GB, you know the calculation, right? Two sectors equal to two sectors equal to something like that, right? So two sectors equal to 512 KB mean, which means you can how many sectors for 20 GB you can calculate this many sectors. Now you need to give last sector information. For example, I wanted to create for 5 GB. For 5 GB, how many sectors required? You need to calculate. If that is difficult for you to calculate, just give size of it. Instead of giving sectors, just give size plus size and then KB, MB, GB, whatever you want. So for example, plus I wanted to give for example 8 GB plus 8G, something like that. 20 GB is there, but 8 GB I am giving. Enter. That's it. It will automatically calculate the sectors here. For example, I'm creating new partition again n. You can see one partition already done, only three are free. So default primary partition I'm creating it. So 2 to 4 default 2, right? Just give enter. Second partition I'm creating it. So default is 167796, this one, right? So if you say, if you take 4194 and all, for 8 GB it took like almost all the things. Now this is actually, until here it took actually 63, until 63 it took for 8 GB, right? Now it is calculating from this sector to from which sector you wanted to create next partition. So for this sector to, and how much GB you want, this is the final last one only, right? So how much you want, for example 5 GB, enter. So something like this you create based on the available sectors you have. You can just set the first sector and last sector information from this place to this place. You can have the space. You can take it. What it's trying to do means, I'll tell you. Um, for example, let's take this is one thing, okay, one disk, for example. Let's think like that, okay. So here 2048, from first to 2048 to how much GB, 8 GB one, this is total 20 GB. So 8 GB until here I'm creating one partition. Again from this place to this is first sector, second partition I'm creating 5 GB, I'm taking 5 GB. This is one partition, right? So something like this, this is one partition and this is one partition, this is for metadata information. Something like this, I created two partitions, one for 8 GB and the one is 5 GB. Almost total 13 GB done, right? So I wanted to write the data again, M for help. If you see here, write data to disk and then exit, right? Just give W and enter. If you are creating extended partition, yes, you can go ahead and create for rest of the data, rest of the space that you have. Now, if you run lsblk command, you can see SDA1 and SDA2. There are two partitions. One is 8 GB and one is 5 GB. You created. These two are primary partitions. Now you need to update to a kernel actually. Okay, you need to update to a kernel. You need to update to the kernel. How can we update means? Part to probe. Part to probe slash dev. Part to probe. Okay. Part to probe slash dev slash SDB. That is a disk, right? So this is the command you need to run. Okay. Let's run it. Part to probe. Okay. Slash dev slash SDB. Just done. Okay. Next, what you need to do is, you need to actually, you have a file system. You have a partition, but you need to convert into a file system, right? For example, you bought a new pen drive, or you bought a new hard disk or anything. You just connect to a system and then you just format the disk first. Once you format, then you can use it. Without format you cannot use it. You're getting it? For example, just baby born, okay. Baby born means what you do, you just like clean it, and then from maybe from first month or second month or third month onwards, like you will you used to talk to baby, right? You used to tell like after 1 year or 2 years, uh, you just say like to brush, and then bathing and all, like you just set some systematic way, right? This is how you need to behave in the home. You need to behave something like this. You need to go to school, or you need to behave something like this, right? You just set some rules, right, to the baby, right? Then only like they follow those rules. In the same way, you just created a partition here, right? You just created a partition here, and then you update to a kernel. Okay, the partition is created. You need to allocate a system here. How you need to allocate means, mkfs.xfs or ext4 or any ext3. What are the file system types that are available based on the based on the spaces and all, right? You have all the things already written here. For ext4, for example, you take until 16 GB to 16 TB, you can create a file system. Can you see? Maximum individual capacity can contain maximum of 64,000 subdirectories and all. There is a limit, right? So all the limits are there. We can read later all this. Okay. So for every file system type, there will be like limitation. Based on that, we create it actually. Okay. Now everyone going for a XFS in the rel 7. So I'm going for XFS. XFS slash dev slash SDB1 first file system. I'll just do a format. I'll just do a allocation of the file system. Okay. Allocate the file system. What I do? You need to run the command mkfs dot xfs slash dev slash sdb1. Enter. See the I know number limit, I know numbers, and everything like all the metadata. You can see it here. It is just formatted. That is done. Right now, you need to you have you have actually like updated. You need to mount it as a file system. So if you want to mount it, mkdir, you need to create a directory for example Ara data or MySQL data, whatever the requirement you got. For example, MySQL data I created. If I want to mount it, I'll just mount using temporarily using mount command slash dev slash sdb1. That is the source device. What is the destination? Slash MySQL data. Okay, just give enter. Now if you run lsblk command, you can see 8 GB. That is slash MySQL data. It is already mounted. Now if you see here df-h disk free space, df-h capital T command you can run disk free space. You can also see it here slash MySQL data. Here 8 GB is size. That is XFS file system, and 1% is full. Nothing we wrote actually, but it is took for some metadata or whatever 33 MB it took actually. Okay. Now you can store in this MySQL. If you go to slash and if you give ll, you can see MySQL data. In this MySQL data partition file system, you can store up to what ma 8 GB. Up to 8 GB we can store the data. Okay, that is the thing. Now you can also like there is one more, right? There is one more left, that is sdb2. If you want to mkfs.xfs, just allocate a file system or format, that is whatever, slash dev slash sdb2. Just give enter. Right now, what you need to do, you need to mount it. Mount slash dev. You need to create a disk first, right? mkdir slash ora data. Okay, so mount slash dev slash sdb2 to slash var data. I'm mounting it to var data. So if you see like lsblk, you can see it is mounted var data. And you can also see df-h capital D. You can also see error data, right? This how you can see. But we just mounted using mount command, right? This is just temporary mounting. Whenever you reboot the server, the mount points will go away. Okay, that is temporary mounting. Whenever you reboot the server, next reboot it will go. So if you want to do a permanent mounting, you need to add an entry in the slash etc fs tab file system table. In this configuration file, you need to add an entry. So first field would be the device or partition that you created slash dev slash sdb1, for which you are trying to mount MySQL data. What is the file system type? XFS. What are the permissions? I am not giving any different permissions. Defaults as a permissions. And last one is last two fields. The first field would be like a file system checkup during boot up. If you are giving one, sorry, backup. Sorry, metadata backup. Zero means it will not back up any metadata. If you are giving one, it will take metadata backup. What is metadata? Metadata means how many files you are storing, how many like directories you have and all. It will just calculate all that metadata information about the file and all. If you want to take the backup of that metadata, you can give one, otherwise zero. And file system checkup during boot up. If you are giving zero, it won't check up actually whenever you reboot the server for next reboot or anytime. If you are giving one, it will check parallelly. If you are giving one for this partition, if you are giving one for this partition, all these partitions or file systems will do parallel checkup. It will do at the time of restart. If you are giving two, which means second priority. second priority, it will do a checkup. Okay, something like that. Okay, so I'm giving one here. Okay, or I'm giving zero. I don't want to do any checkup. Now there is one more, right? Slash dev slash sdb2. Okay, I'll give slash vara data. One a incorrectly I'm giving. Let's see what will happen. xfs defaults. Okay, zero. I don't want to check. I don't want to take metadata backup. I don't want to check file system during boot up. Okay, just say one. You need to validate those entries. If you miss something and then you did incorrect. Okay, you can do mount option a command you can run. It will actually check. Okay, see, oracle data does not exist. This mount point does not exist. This mount point mean directory, right? It is not exist, right? We need to correct it. Okay, data, there is something wrong here, so you need to edit it, something like that. You can get to know mount option is the command to validate. Okay, you already know there are different things here, right? A you can remove it, save it. Now let's run mount hyphen a again. It will get refresh. Definitely, if you are making changes to slash edcfs tab, you need to actually refresh the disk. Otherwise, it will not work. Okay, it will not take effect. We can run mount command now. You can see mysql data xfs slash vara data xfs, and you can see the partition that we created. Okay, this is called primary partition creation. Okay, guys, anyone have any questions, any doubts in this? If you have any questions, let me know. Okay, and I'll be uploading this to our channel. Just go through that once after this session. Let me know if you have any questions. You can comment, or if you're anyone not subscribed to my channel yet, just subscribe. Okay, and then you can watch it. Let me know if you have any questions, then I will discuss on that.